All right, this is our second example of an introduction to doing derivative. Derivative is always going to refer to slope. So we're kind of doing some pieces of it, and we'll get to the definition eventually in a different video. But here's what we're looking to do. It says find the equation of the line tangent. So we're looking at the tangent line of this equation at this point. So this is a point on that graph, right? So at the end of this, anytime we're talking about a tangent line, we are going to be doing y minus y1 equals m times x minus x1. Okay, so very much something that was introduced in an Algebra 1 class. And once we find these pieces, we're going to eventually turn it into a y equals mx plus b. All right, so that's what we're looking for, but this is what we're going to use to find that. So what do we need? We need two pieces of information for that formula over there. We need a slope and we need a point. Well, we got the point, so that's good. We need a slope and point. Point's good. Slope, that's what we figure out. So we're going to find the slope of the tangent line. So if you were in an Algebra 1 class, they might talk about a slope being parallel or perpendicular, or they give you 2 points and you're going to find the slope between them. We're kind of going to do something like that. So for our slope is, we're finding the slope of the tangent. So that means that we are going to be doing the limit as x is going to be approaching this value, 2. Okay, we're trying to find the slope at this point. So as x approaches 2, we're going to be doing f of x minus f of 2 divided by x minus 2. All right, so we're trying to squeeze this x, getting closer and closer and closer to this y value at 2, and then same thing on the denominator. All right, so let's sub in what we have. So as x approaches 2, f of x is this equation. So 3 over x minus f at 2 is this coordinate. So it's literally 3/2. Otherwise, I could plug into, and then this is the value that I would get. But f at 2 is 3 over 2 over x minus 2. All right, so problem is right now, if I were to plug in 2, because our limit is x approaching 2, if I plug in 2, I'd have 3/2 minus 3/2, and I'd have 2 minus 2. So I would get a 0 over 0, which is a whole, which means I got to do a little bit more work to this, right? That also means the limit exists, but I got to figure out how to find it. And to find it, we got to do a little bit of manipulation, right? So here's what we're going to do. We are going to, let's put the top together. Let's make it a fraction over a fraction. And then we can multiply by the reciprocal kind of a thing. So to do that, though, we need to find a common denominator, which would be a 2 and an x, which means this needs to be multiplied by x, and this needs to be multiplied by 2. So you did 2x here, and you get a 2x here, but however I change the denominator, I need to change the numerator equivalently. So we're now looking at the limit as x approaches 2 of 6. This 6 over 2x minus 3x over 2x. And then that's over our x minus 2. Okay, so the reason I get these common denominators is because now I can put the fraction together. As x approaches 2, can't drop that until I plug in that value. So we're going to get a 6 minus 3x over that common denominator of 2x over this x minus 2. All right, kind of a mess. But what we do here is we're going to be looking to simplify this. So we're going to take this fraction, limit as x approaches 2, and this fraction, 6 minus 3x over 2. And instead of dividing by this, right, we would be dividing by, let's make this a fraction. So instead of dividing by x over 2, we're going to be multiplying by its reciprocal, x minus 2. All right, so remember that back here, if I were to plug in 2, we get a 0 over a 0. So if I plug in 2, there's my 0, there's my 0. So I need this x minus 2 to go away, which also means that I bet x minus 2 is a factor of this. So I'm going to take advantage of the fact that I know that this is what I need to cancel out. And I'm going to divide out what it takes to get an x minus 2. So it's kind of like I know that needs to happen. Okay, so let me come back to that in just a second. All right, so what am I going to take out of this to make it an x minus 2? Well, to make that just an x, I need to factor out a negative 3. And if I factor out a negative 3, that becomes x. If I factor out a negative 3 out of 6, that becomes a negative 2. Right? Perfect. That goes away. I'm now left with the limit as x approaches 2. Right, so again, that's good because that's taken out my problem. That's my 0 over 0. So now I'm left with a negative 3 on the top and a 2x on the bottom. And now if I plug in 2, no problem. So we're ready to drop the limit sign because we're going to be plugging in 2. So we have a negative 3 over 2 times 2, which is negative 3/4. All right, so that, put that back in, that's our slope. So, perfect. Now we're ready to finish this whole thing up. So y equals, or so y minus, so we needed a point in the slope. We found our slope. We had to use calc to get there. Right? This is very much leading us to the actual legitimate calc. And I have my coordinate, which this is my x1, this is my y1. So it'd be a y minus 3/2 equals negative 3/4 x minus 2. And so we'll distribute, we're going to add that over. So y minus 3/2 equals negative 3/4 x. Negative and a negative are a positive. That would be 6/4, which simplifies to 3/2. All right, and then I'm going to add 3/2 to the 3/2. So that's going to be 6/2. So then our final answer is going to be plus 3. All right, I'm gonna do one last thing is I threw this into Desmos to kind of see, make sure everything lines up and does what it's supposed to do. So let me share my screen. All right, here we go. So here's our graph. This is that 3 over x, which was our original function. Here's our coordinate, right? So there's our 2 3/2. And then what we're trying to find is this equation, which is what we just found, which was our linear, our tangent line. And so if we did this right, it should pass through, have this negative slope, which I agree, and then it should just be grazing through that, right? So there's a nice way to check to make sure everything did what it was supposed to do. All right, so that was finding a tangent line to this graph at this particular point, and these are the steps involved.